Okay, in this video, I'm going to be going through question number 17 from the practice exam. This is a question about calculating a confidence interval, which is something useful when we don't know the actual population proportion. We're only able to collect samples, and then we create a range of values around which we're fairly confident the true population proportion would be included in. This question 17, it has multiple parts to it, A, B, C, D, E, F. But as the quarter goes on, those individual parts are going to be removed, and you may just see this much of the question, and we'll then need to know that you're going to need to follow each of these steps in order to obtain the confidence interval. So it says 186 Jeep owners were asked if they frequently use their vehicles off-road for traveling. Only 12 said they did. Calculate a 95% confidence interval for the proportion of Jeep owners who frequently use their Jeeps off-road. So first thing it asks us, part A, what is the point estimate? So the point estimate is going to be the center in our range of values, and maybe an easier way to think about the point estimate in this case is it's really going to be the same thing as calculating what the sample proportion is from the data we've been given. So if we are to calculate the sample proportion, we know it's going to be equal to the number of successes over the total sample size n. In this case, we're interested in the proportion of people who frequently use their Jeeps off-road, and 12 of those surveyed said they did. So in this case, there would be 12 successes out of a total sample size of 186. So now I just need to go ahead and type that into my calculator. 12 divided by 186. And keep in mind that all values we're going to be calculating this quarter, with the exception of z-scores, we want rounded to 3 decimal places. So I'm going to have 0.06, and then that 4 will be rounded up to a 5. So this is what our point estimate would be, 0.065. So that's just telling us in this one particular sample, about 6.5% of the respondents said they frequently use their Jeeps off-road. If we were to take a different sample, we're likely to get a different proportion because most sample proportions differ from one another versus a population proportion, which would be a fixed value. Okay, so moving on to part B. Part B asks, what is the critical Z value? So a critical Z value, that's not something you're going to actually need to calculate, but more something you need to know, either have memorized or have in your notes. So a critical Z value is denoted by Z sub C, and what your critical Z value is depends on the confidence level that was chosen. So in this problem, we're using a confidence level of 95%. Other problems, you may be using a confidence level of 90% or 99%. But that's what helps us to determine the critical z-value. Again, these are the three most common ones we'll be using. So you can see there's a separate critical value for each confidence level. In this problem, we're using a 95% confidence level. So my critical z-value is going to be 1.96. And that's it. That's all I need to do to answer that question. That value, the 1.96, which again came from using a confidence level of 95%. This isn't just a random value that came from nowhere. If you remember last quarter, we had learned that based on the empirical rule, approximately 95% of values in a normal distribution are within 2 standard deviations of the mean. Well, that 2 standard deviations was more of an estimate, just a nice, easy figure to use. The actual approximate value is actually 1.96. The empirical rule just rounds it to 2 to make it easy to work with. So, more precisely, 95% of the sample proportions are going to be within 1.96 standard errors of the population proportion. Okay, so next, see what is the standard error. So remember that sample proportions are just estimates for the population proportion. So each sample proportion has some amount of error to it. The standard error tells us the typical or average error in the sample proportions. So to calculate this, we are going to need to use a formula here for standard error. And you might be more familiar to using the formula that was used earlier in this module that started out looking like this. This we can use when we know the population proportion. Here we don't. We're just working with the sample proportion. So this is more an estimated standard error, but it still works the same way. We're going to take the square root of p hat times 1 minus p hat divided by n. And we know from earlier parts of the question already what our values are for p hat and for n. P hat, the sample proportion or point estimate, was 0.065. And remember, n is our sample size, which was 186. And so now it's just a matter of plugging those values into the formula. So I'd have 0.065 times 1 minus 0.065 divided by 186. And I'm going to type that into my calculator and round to 3 decimal places. And I'm going to come up with 0.018. So in this case, our standard error is 0.018. Okay, moving on to part D. Part D is asking what is the margin of error. So it's important that you know there is a difference between the standard error and the margin of error and how to calculate each of those. We know that the sample proportion is likely not equal exactly to the population proportion, although we expect it to be close to it. And so the margin of error tells us how close we expect it to be. They use capital E for margin of error, and we can calculate the margin of error by multiplying our critical Z value by the standard error. So these two values we've already determined in parts B and C. So our critical Z value was 1.96 because we're using a 95% confidence interval. And the standard error, which we just calculated, 0.018. And now I'm just going to go ahead and multiply those two together on my calculator and round to 3 decimal places. And that's going to give me 0.035. So this would be our margin of error. So that tells us that 95% of the sample proportions are within 0.035 of the true population proportion. Or 95% of random samples of size 186 will have sample proportions with at most 3.5% error. Okay, so moving on to part E, what is the confidence interval? So now we're going to actually calculate the confidence interval, or that range of values around which we're 95% certain contains the true population proportion. So our confidence interval will end up having two values, sort of a low end and a high end. And we calculate that by taking our point estimate or sample proportion and then either adding or subtracting our margin of error. So to get the low value in our range, we'll take the point estimate and subtract the margin of error. To come up with the high value in the range, we'll take the point estimate and add the margin of error. So our low value, I would have my point estimate of 0.065, from which I'll subtract the margin of error, 0.035, and then to find my second value, the upper value, again I'll take my point estimate, 0.065, but this time I'm going to add the margin of error, 0.035, And so you can see when you're done, you're going to have two values inside a set of parentheses with a comma separating them. So on my calculator, if I do the math here, 0.065 minus 0.035, rounded to 3 decimals, I'm going to get 0.030, comma. And if I calculate the high range, 0.065 plus 0.035 rounded to 3 decimals will give me 0.100. So this is what our actual confidence interval is going to look like. So I have the range of values, low to high, inside parentheses with a comma separating them. So that brings us to the last step, one of the most important steps. F, interpret your confidence interval in the context of the problem. So I need to explain in plain English sort of what our answer, our confidence interval means in relation to the problem about Jeep owners. When you're answering this part of the question, interpreting the confidence interval, you do always want to start by stating what confidence level was used. So in this case, we had used a 95% confidence level. So I'm going to start out my answer by saying we are 95% confident that. And now what we're confident about, which is that the true and here you sort of have a choice to make. You could either say proportion or percentage, and that depends on how you're going to use these values in your explanation. If you're using them like you see here in decimal form, you'd want to use the word proportion. But if you're going to convert these to their percent form, then you could use the word percentage right here, and you can choose either one. It's perfectly okay. So I might do the percentage. So we are 95% confident that the true percentage. And now I want to relate it back to the problem, and I want to make sure I'm being specific and including all the little descriptors. So we're 95% confident that the true percentage of Jeep owners who frequently use their Jeeps off-road is between 3% and 10%. So again, it's important that we're including all the descriptors. We're talking about Jeep owners. We're talking about those who not maybe sometimes go off-road, but frequently take their Jeeps off-road. And here I'd use the word percentage, and I've used the percent values. Again, I also right here could have used the word proportion and then used the decimals. So I also could have said we are 95% confident that the true proportion of Jeep owners who frequently use their Jeeps off-road is between 0.03 and 0.1. So we are 95% confident that this interval here between 3 and 10% contains the true population proportion. This method accurately estimates the true population proportion 95% of the time. So if we were to do this 100 times, so on 100 different occasions, I take a sample of 186 Jeep owners and ask them about how frequently they use their Jeeps off-road. We would expect that 95 out of those 100 samples are going to give us a proportion somewhere between 3% and 10%.